Um, the past couple days, we've talked about linked lists, stacks, queues. I figured we could spend a little bit of time today going over some examples, maybe writing some code, um, implementing some of the things that we saw in lecture. Uh, before starting that, are there questions or clarifications on previous material? Nope. All right, cool. Um, oh, a couple of questions. Excellent. Go for it. Yes. What about them? Fair enough. I wouldn't worry too much about that jump and long jump. You can find like examples online if you need to use them. I mostly included that as like uh, a cool thing that's technically possible. Um, we might write an example with set jump and long jump today, so you can kind of see how those work. Um, yeah, you can sort of just think of them as like go-tos in some sense. Any other questions? Cool. I guess we should go over some course logistics things first. Uh, so you will get your first problem set will be released on Friday, and you'll have a week to do that. So it'll be released on the 14th. It'll be due on the 21st. Um, we're planning on releasing the first programming assignment next Monday, which is the 17th. But if things are ready before then, and if people want access to it early, we might release it a couple days early, especially because we're kind of going through material a little bit faster than I expected. Um, but either way, that'll be due 2 weeks from the Monday when it's released, which I believe is July 1st. So some assignments coming up in the pipeline to look forward to. Also, I made a post about this on Piazza, but with the attendance poll stuff, I didn't realize that there were so many people in like different time zones and stuff. So I am further extending the time that that stays open. And so the poll from yesterday will be due today, or the poll from yesterday will close today at noon, and the poll from today will close tomorrow at noon. And so you'll have like a, I don't know, not 36 hours, but like a 30-hour window or whatever that is, to complete them. So hopefully that should help with time zone things, and hopefully that should give you a little bit more time to watch the lectures and stuff. Oh, and finally, the first exam, I've had a handful of people email me already about not being able to make the regularly scheduled time. Um, if that applies to you, if you won't be able to make the normal midterm time, please reach out to me as soon as possible so that we can get something scheduled and I can make sure that either me or one of my TAs are available to proctor it. Um, so far, I think we've got people taking it later in the day on Wednesday, so like Wednesday evening, and then some people taking it the day after, which is Thursday. Um, so yeah, try to figure that out as soon as possible and send me an email if you won't be able to make the midterm. All right. Any questions on logistics stuff before we get started? Sounds good. Um, I did release the Q's lecture on Brightspace yesterday. There was like a slide or two that we didn't get to at the end. I'm not going to pull the whole thing up just to go over those. They're basically just talking about different kinds of queues. I encourage you to take a look at that. Um, it's material that we will cover at a different point in the semester anyways. I think mostly it was about like heaps and priority queues and stuff. So we'll talk about that in like a couple weeks. Um, but yeah, if you want to take a look, the slides are all posted. So today I figured we could start with me sharing my screen. Wait, which this one? Yes. Okay, cool. Can people see my VS Code screen? Complete. Oh, chat. I should keep this open. Yes, wonderful. Okay. Okay, so I figured oh, also if I type here, is that visible or should I zoom in or change the colors or something like that? I can't quite tell what it looks like on the recording. Okay, zoom in slightly. Is that better? That's better. Okay, awesome. All right, so I figured we could kind of go through some of the theory stuff that we talked about the past couple of days and try implementing it. And maybe I'll make some mistakes and maybe I'll have you all tell me what I've done wrong or like what I should do next or how to fix it or what we expect to happen or whatever. So we can have this be sort of interactive. Does that sound good? Ooh, did you know Zoom does that? That's pretty cool. I didn't. That's cool. All right. Anyway, so all right. Um, we'll create a node struct, right? And we need a next, and we need, let's say, int value or something like that, right? Now, if I want to create a header for my linked list, um, can anyone tell me what fields I need in a linked list header? Just a simple, like singly linked list. It's not circular. It's not anything fancy yet. 2 pointers, head and tail. Thank you. So I'll go struct node head, struct node tail. Okay, cool. Now, let me include std bool. For the record, I am writing this like live. I didn't pre-write this to like copy and paste or whatever. So if I legitimately do make mistakes, that is entirely possible. Um, please yell at me to correct them if and when that happens. So the first thing we can do is maybe um, find out if a linked list is empty, right? Okay. How do I know if a linked list is empty? Uh, if I use null to if like the next of the last node is null, if I use that to like signify the end of the linked list, I can check to see if head is null, right? Right? Or I guess I can just return head equals null. Maybe I want to say header dot head equals null, right? Does that make sense? I guess we should write some code to initialize our linked list. Right. What should I initialize head and tail to if it's an empty linked list? Like before I've allocated anything, before I've inserted anything. Null, thank you. So we'll say list.head equals null, list.tail equals null, then we can return list. Okay. Um, so yeah, if it's empty, like it is when we've initialized it, we just check to see if the head is null. now we can do insert head, right? Okay. Um, so the first thing I need to do if I'm inserting a new node is I have to actually create the node I'm going to insert, right? So this is going to be new node equals malloc size of node, right? And then maybe I cast this, right? And then I can say new node. Oh, I should say struct node, right? This is C. Struct node. And I can say new node um, value equals value. Okay, I've created my new node. What do I set the next of this to? Null. Okay, interesting. If I'm inserting something at the head of this linked list, right? Um, the former head. Thank you. Yes, I set this to header dot head. Does everyone see why? Because new node is going to be the new head of the list, right? So its next should be whatever the current head is. And then I can update head. Oh, I should pass this via pointer, shouldn't I? So that I can change it. Okay. And then, so does it make sense why I'm setting it to this instead of null? Perfect. What do I set header dot head to? What's the new head of the linked list? New node, thank you. Cool. Okay. Let's insert at the head. Let's insert at the tail. Okay. So maybe I can start by doing the same thing where I create a new node. Okay, what do I set the next of this to? If it's the tail, if it's the new last node of the list. Null, thank you. Perfect. Does everyone agree? It should be null. I'm assuming that's a yes. Um, perfect. Thank you. Okay, so I've set new node next null. What else do I have to do here? What am I missing? I assume I need to set the if I'm inserting this at the tail, it needs to be, well, do I free? What am I freeing? I've allocated a node here, right? I'm creating something. Make the tail point to it. Thank you. So header tail equals new node, right? Um, is this correct? Have I missed anything? The previous tail must point to it. Well, I see. Yeah, so we can say header tail next equals new node, right? That way, I got a shiny new toy yesterday. This tablet thing that I can try to write with. Um, I'm gonna try to like annotate. It's like a knockoff Wacom. Yeah. Um, it was sold to me as being compatible with Ozu as well. So um, I'm looking forward to that. But let's see if I can annotate. There we go. Ah, yeah, this is cool. Okay, so if we draw out what's happening in insert tail, right? I've got my header. I've got a linked list. Maybe it's got two nodes in it right now, right? The head is pointing here. The tail is pointing there. So if I create a new node, have to create my new node first, right? This is going to be new node. And then if I want this to end up at the tail of the list, the first thing I need to do is obviously have it point down to null. But then if I need to make this the end of the list, then I need to make the current tail point to it. And then I need to update what I think of as the tail of the linked list. Right. So I allocate the new node here. I set it's next to the null. I make the tail point to it. And then I update what I call the tail. Cool. All right. Thank you for obliging me with that. Let's keep writing code. Okay, so I can insert at the head, I can insert at the tail. What happens if I try to delete at the head? Um, yeah. What do I do to delete the head node? Right, so if I look at header head, okay, so I can set head equals next. That's fair. Oh, I should check if it's empty, right? If not, what do I call it? If not is empty, header. All right, what's everyone's favorite error handling strategy for this? Maybe we can try assert. Right? So I can maybe assert is empty header, right? I'm dereferencing it here because for some reason I wrote is empty to just take this by value instead of by pointer. Okay, so if I just do this, this will effectively delete the first node. What's wrong with this? What happens if I run this code? Actually, maybe we can try it, right? So we can say linked list, my list equals init linked list. And then we can insert head. Ah, yes, thank you. We must free it. Okay, so maybe I can say, okay, is this correct now? Okay, um, let's try this. Right, so we expect it to be empty first and then not empty. Um, what? What did I do wrong? What's the declarations? You need to insert SG, okay. This is why you don't code live. Okay, maybe I'm gonna turn off pedantic. What? I have to say struct here. Does anyone know what this problem is or what this issue is? Oh, unknown type. Yeah, okay. It's because I have to say struct everywhere. Sorry, I'm used to writing C++. Um, so this happens sometimes. And then of course I need stdlib for malloc and free. I guess this is why people type diff, right? Okay. There we go. All right. Okay, cool. So it's empty, and then it's not empty. Let's do this. Okay, cool. Um, that was maybe more work than it should have been for me, but that's okay. Okay, so let's write delete tail. Okay, so of course we have to assert is empty on header. Actually, let's see what happens if we try to delete the head of an empty linked list, right? So if I delete head, right? And then let's try this again, right? So first of all, it should be empty here. I've inserted something, so it should not be empty. I've deleted the head, so it should go back to being empty, right? So now, if I try to delete the head again, it should crash. Perfect. Okay. So you can see it prints a nice error message. Line 48. Yeah, that's where the assertion failed, right? So this is how assert works. If instead we did something like if not is empty header exit one, then it would exit, but then if we printed the return code, it would print one. Whereas if I didn't have this, hmm. Oh, interesting. Okay, so so apparently the first delete head fails. Is that right? Can anyone figure out why? Yeah, it gets to here and then it fails. Um, because I flipped this around. There we go. All right. Is this good so far? All right. Let's try deleting the tail. I'll start with my assert. Okay. Um, Now what do I need to do? I can grab the node to delete, right? Header tail. Check if empty. Okay, if not, traverse to where node.next.next equals null. Okay, let's try that. Traverse to where node next equals null. And then make node next null, then free the tail, and then make the tail the current node. Okay, let's try that. So I'll start with struct node, maybe I'll call it like current equals header head, while current next does not equal null, and current next does not equal null. Right? And now current is the new tail, right? So what can I do now? Say current next equals null. I can say header tail equals current, and then I can free to delete. Is that right? Have I missed anything here? Okay. Let's maybe write a function to iterate through a linked list so that we can see free to delete before reassigning header tail. Okay. Why do you say that? So you're saying I should move, oop, you're saying I should move this up? Interesting. So when I access header arrow tail here, it's not like it's accessing the actual pointer value here, which means if I reassign this to a new pointer, it's still going to keep the old one here. Right. So it should be fine either way, but we can try it. Um, let's just write like a write a print list function. And so we'll say okay. So I think I want a loop. What should my loop condition be if I'm just trying to like iterate over the entire linked list and print every element? Okay, let's say cur next does not equal null. I can printf. What do I want to print? I want to print cur value here, right? Okay. Um, will this correctly print the list? Who thinks it will? Ah, cur does not equal null. Thank you. All right. Now will this correctly print the list? Let's find out. Insert a couple things at the head, and then let's call print list.
You don't have your current updating in the print loop.
Thank you. All right. Is this better? 432. Yeah, that's what we expect, right? We insert four at the head after, so the most recent head should be four. Yeah, okay, perfect. That's correct. Um, okay, now that we have, well, okay, actually, let's try deleting the head and then print again. And let's try deleting the tail and then print again. Okay, so we know this one prints 432. What do we expect this one to print? 32. Okay. And what about this one? 3. Okay. Let's see if that's accurate. Okay, I don't know why all the fours keep showing up. I think it thinks it's important, but yeah, 432, 32, and then 3. Perfect. Okay. Um, maybe we can be reasonably confident that our linked list stuff kind of works. Um, let's try implementing a stack. Oh, I maybe could have separated it out into separate files and like linked them together or whatever, but I'm not going to do that. Okay, so if I'm going to implement a stack via linked list, right? What fields do I need in here? How do I use a linked list to build a stack? Do we need to find head as the top of the stack? Yeah, so we are going to treat the head as the top of the stack, right? So the first thing I'll need is the actual um, list, right? And then I'll say like list head is the top. Okay. Do I need anything else in here? If I'm just treating this as if I'm using this linked list as a stack? Let's assume I don't, and then if I do, we can add stuff. Okay. So, what are the two operations that I can do on a stack? How do I insert? What's that called? Push. All right. We'll take our stack list. We'll take our struct stack list, and then we'll take our value, right? How do I push? Can I put pop and push into my struct? You mean something like this? Like that? Eh. Uh, if this were C++, I could, but this is C, so structs are just like data, right? So I have to pass the struct as the first argument to each of these, right? I'll insert at head. Okay, so insert head, and then I'll do stack value. Does that seem correct? Does that seem fine? Are people okay with that? Not sure. Okay. Well, let's try moving on, and if there's an issue, then we can figure out what it is. Okay, how do I pop? Delete head. Okay. But now from pop, I need to actually return something, right? I can't just delete. How do I get what to return? I have to peek at the head, right? I have to say stack, what do I call it? Stack list head value, right? Use a temp value to hold the head, then delete head, and then return. Okay, maybe I can do that. Does that track? What's wrong in both of these functions, by the way? Maybe it's not obvious like this, but maybe if I split screen and then take a look at delete head and delete tail. These take a pointer to a linked list. I'm passing in a pointer to a stack, right? So I have to actually get the list out of the stack. Okay. And then let's maybe initialize this. And then we can say stack equals init linked list. Okay. If I say struct stack s equals init stack list. Right. Let's push. Actually, let's do this. Let's push into s I times 2. Okay, and then let's do while not is empty. S dot list. Int value or int top equals top s, and then printf opt that. Okay. So what should this print? First of all, what should it push? Right, it'll push 0, 2, 4, 6, 8. And then when it pops them, what's it going to print? Eight, 6, 4, 2, 0. All right. That's a good guess. Let's find out if that's accurate. What in the world? In function init stack 191. Oh, right, because I have to return the stack. This is ridiculous. Ah, there we go. Okay, so 86420. Perfect. Okay. Um, that's a stack with a linked list. Does that make sense to everyone? Are there questions? Are there uh confusions? Before we move on to stack with an array? Yes, what's up? Why did I not define the functions as returning a pointer? Are you talking about pop and push, or are you talking about init? Okay, you can stick around after class if you want, or send me an email. Okay, so if I'm implementing a stack with an array, assuming there's no other questions, what all do I need to keep track of? Let's go ahead and call this stack array. Okay, yep, I need the stack pointer. What else do I need? Maybe let's start with this, right? So if yep, I need a buffer. What should the type of my buffer be? int buffer. Okay. Does everyone agree? Static? Why should it be static? So the buffer is like the underlying array for the stack, right? If I pull out my favorite thing once again. Yeah, there we go. So if you remember from the slides, right, we allocate an array and then we keep a pointer to the current top of the stack, right? Yeah, int pointer. It should be int pointer. Okay. Is that enough? Do I need anything else? I feel like there's something I'm missing, but maybe we can run with it. Doesn't the stack pointer have to be a pointer? Yeah, so we could make this a pointer and have it like point directly into the array, or we could just leave this as an index, right? And then I could just use like buffer at SP instead of dereferencing SP. Both are fine. I'm gonna leave it as an index, but you're right. It is morally like a pointer into this array. Or you can think of it as like an offset into this array or something. Okay, so let me clear this annotation. Okay, what do I initialize the stack pointer to? I kind of alluded to this earlier with my drawing. But where does the top of the stack start? Anyone have guesses? Zero. Okay, pretty good guess. Um, what about my buffer? I need to allocate this, right? How big should we make it? Maybe we can use the alloc here. Let's start with 8, right? So I can initialize a stack array. And then I'll write array versions of push and pop. Okay, this I feel like is a bit more interesting, right? So we'll do push array, and we'll take struct stack array stack, and then int value. How do I push into a stack array? Cool. Okay, so stack at array is going to be buffer, so I'm going to call this buffer, and then SP is going to be stack arrow SP, increment equals value. Everyone go with that? calloc, yeah, I guess I can use malloc instead. Calloc is a function similar to malloc that just clears the memory before it allocates it. So it allocates memory for an array of a certain number of elements of size bytes each. So it's equivalent to doing this, but it zeroes it out first. I guess I can just do this. Shouldn't we check that we haven't overflowed on the push before assigning a new value? Yes, thank you. I was going to purposely run into that particular issue to get someone to say that, but thank you for saying that. Yes, we should check to see if we've overflowed. How do we check? How do we check for an overflow? Okay, if SP stack SP is greater than. Okay, so I don't have a buffer dot size, so maybe I need to include that, right? So I can say like int buff size, and I can initialize that to 0, or initialize that to 8. What should I check for here? Or what should I do if the stack is going to overflow? Rid of it. Yep. For now, let's just assert false, and then we can think about better ways to handle this. Okay. So assuming that we've correctly handled overflows, does everyone agree that this is the right way to push? Assuming there's no pushback against that. Pushback. How do we pop from a stack? From a stack backed by an array. If push writes to the stack pointer and increments it, what does pop do? Return the value and set stack pointer back. Okay, so if I do something like return decrement stack pointer, is this correct? Pre-decrement, thank you. Is that good? What do I have to check for here? Is empty. Okay, so is empty is a predicate on linked lists, right? Our stack is backed by an array. Check if SP equals 0. Perfect. And again, for now, let's just assert false. If not, SP is less than 0. We could check to see if it's greater than or equal to 0. The problem is if it equals 0, this is still going to be an issue, right? Because I will literally take any excuse to write. Let's do this. So oh. Okay, if this is our stack, right? SP, like maybe I've got a 2 here and a 3 here. SP is going to point to the first empty spot, right? Which means that's why I decrement it first. I decrement it to here, and then I pop this value. If SP points to 0, or if SP is 0, then there's nothing in the stack at all. If I try to decrement it first, it'll end up pointing off into space, right? Because I'm pre-decrementing. So I need to check. I can't just check if it's greater than or equal to 0. It's not safe. It has to be strictly greater than 0 to be safe. All right, let's do that. Okay, so does the SP++ in push array increment before inserting the new value? No, so here it inserts the new value into the current stack pointer, and then it's a post increment, right? Like the difference between x plus plus and plus plus x is that this reads the value of x and then as a side effect increments it. This one increments it as a side effect and then reads the value of x. The stack pointer itself it's not empty, but it starts at 0, right? So it points to whatever the it's just an index into the array. It's just like the offset of where we write. Okay. So assuming we've implemented all of this correctly, what do we expect to happen here? If I push, what should it push? Let's find out. Oh, good. Never named list. Array. Oh yeah. Um, or let's just do this. Okay. So same thing with the list stack. It pushes 0, 2, 4, 6, 8, and then it pops them in the opposite order. So 8, 6, 4, 2, 0. What happens if I make this 10 and pop 10? Can anyone predict what this will do? Overflow, right. And what did we have it do on an overflow? Just gonna crash. Perfect. It crashed before popping anything, right? Which is good. Now, is is a crash the best thing we can do on on a stack overflow for an array-based stack, or can we do something else? Right. I have this to do here to handle this a better way. What's a better way to handle this? Grow the stack to double the size. Excellent. Okay. So let's grow the stack. Right. You said double the size. So let's start by saying new size equals stack buff size times 2. Let's maybe we can use realloc for the buffer, right? So I can say like stack buffer equals int star realloc or maybe I'll just call it new size, right? And I can say right. Does that seem fine? Now if I do this, it'll push 0, 2, 4, 6, 8 all the way up to 18, and then it'll pop them in the reverse order. And we can kind of prove to ourselves current, let's see, pushed current stack size, and we'll say we pushed I times 2, and then we'll print s dot buff size. Right. Okay. Yep. So when we push 0, 2, 4, 6, 8, 10, 12, 14, right? This is the 8th thing we've pushed. That's fine. But as soon as I push 16, it goes over the stack limit. And so I have to double the size. And so the stack size becomes 16, right? So we can see that kind of works as expected. Does anyone have questions or confusions or clarifications about any of the code we've written so far, or any of the stuff we've covered in lecture or course materials or anything like that? Right, okay, so doubling the stack size right here. I calculate what the new size is, right? So here I'm just saying buffer size times 2. Instead, I could say like buffer size plus 4 or something like that. But we talked about like doubling being a better thing to do. And then I use realloc, which allocates a new bit of memory and then copies stuff over from the old bit of memory. Right, so instead I could just say like something like malloc, and then for like copy, right? But realloc does that for me. Important to note that even though it's one line of code, like this still like effectively loops over everything. It just loops a little bit faster than an actual for loop would be. But yeah, we grow the stack like that. It's not the only thing, right? So instead, we could grow it by 4, let's say, right? So we add 4 each time. Maybe this time I'm gonna push out to 20, right? Let me pull this up, let me compile and run. Invalid next size. Oh, I think realloc might actually care. But let's just do this manually. Um, uh, int new buff equals that. And then let's say buff buffer I. We can say stack buffer equals new buff, right? Yeah, there we go. Right. So I can start at 8, bump it up to 16, bump it up to 24, or like I can make it grow by 4 instead, right? So it starts at 8. When I run out of space, I move it up to 12. When I run out of space, I move it up to 16. When I move it up to 20, I can just keep going like that, right? We will see when we talk about time complexity and amortized analysis and stuff like that, why it's better to grow by a multiplicative factor. But yeah, you could do anything. You can grow it by 1 every time. Okay, for an attendance poll, because yeah, I can post this code on Brightspace. Right, cool. Okay. For an attendance poll, maybe tell me why you might use different error handling strategies. Like what error handling strategies we talked about, right? So there's assert, We talked about like exiting early. We talked about doing other stuff. Uh, tell me what circumstances you might use these different things in. All right, and with that, it is 9:42. I'm going to stop sharing my screen. You are all free to go. Sorry, I went a couple minutes over. Feel free to stick around if you have more questions, but yep. Talk about the different error handling strategies that we talked about in lecture, and maybe say why you might use one over the other, or like what circumstances you might use one in over the other. You mixed up trees with linked lists.
Oh, can you hear me? Sorry.
Yeah, I can hear you now.
Yeah, so I was kind of thinking of like a struct like node pointer, and then I was expecting to return like a memory address. That's why I was like, wait, why aren't we doing that? And I was like, oh wait, we're not doing trees.
Ah, gotcha.
Yeah. But I think should be good.
Yeah, okay. So the attendance poll is talk about the error handling strategies that we discussed and maybe when you might use one over the other.